A C++ program is basically a collection of statements and expressions, usually organized into functions and classes. In this lesson, I'm going to show you the general anatomy of a C++ program. Please understand that this is not intended to be exhaustive. We'll be going over each of these concepts in more detail throughout the course. For now, it's just important that you have a general overview of how these things work. Here in Xcode, I've opened a working copy of hello.cpp. And the first line of this program, you'll notice these two slash marks followed by some text. This is called a comment. A comment is something in the source code that is not actually interpreted by the compiler in this case, and so it's ignored. And there are two styles of comments in C++. This is the line-oriented comment, and so anytime I put in two slashes, like for instance, if I put in two slashes down here, and I can type whatever I want, and it doesn't actually change how the code works. So I can save that, and I can compile and run it, and you see that it runs the code. Now, if I take this comment out and save it and compile and run it, you see it works exactly the same. Now, as I mentioned, there's two styles of comments in C++. That first style is with the two slashes, and technically speaking, whenever you put in two slashes and some text, the comment extends to the end of the line, and the beginning of the next line starts code again. So if I wanted to have multiple lines of comments using the slashes, I would have to put two slashes at the beginning of each line, and those would work as comments. Another common way to have multi-line comments in C++ is to use one slash followed by an asterisk to introduce the comment. And now you notice that all of the code in my program has turned to green because it's all being ignored. It's all part of the comment. I can terminate the comment by putting in an asterisk and another slash, and now everything between the slash asterisk and the asterisk slash is considered a comment, and I can put in paragraphs of text here. And when I compile and run, you see the program still works exactly as intended. So that's how comments work in C++. Generally speaking, a C++ program is a series of tokens. And these tokens are separated by white space. The white space can be simply a space, like it is here, or it can be new lines. You can put these things on separate lines, and they'll still work exactly the same. It's just harder to read. And so we tend to think of things in terms of units. So this whole unit here, this function definition, is like all one thing, and so we tend to put it all on one line, but it doesn't actually have to be that way. The compiler doesn't care. So before we get to the main function, there's a couple of other things here. You'll notice this line that starts with the pound sign. This is actually an exception to the rule that I just gave you about white space, because this is a directive for the preprocessor, this pound include. And so we'll cover the preprocessor in a lot of detail later on in the course, but for now, know that when this pound include happens, it violates a lot of the rules of C++ because it's not actually C++. It's a preprocessor directive. And so there's no semicolon at the end of it, and the new line at the end, that line separator, is actually significant. So all of this must be on one line by itself. So pound include with no space between the pound sign and the word include, and then a space, and then the name of a file inside of either quote marks or angle brackets in this case. And the angle brackets and quote marks mean different things. Again, we'll get into the details later. But what this line does is it includes a standard library file, a header file. This tells the preprocessor to take that file and include it in this source code file as if I had typed it. And it's hundreds of lines of code, so I don't want to type it. So simply saying include cstdio like that, it tells the preprocessor to do this for me so I don't have to do it, and that's actually pretty cool. The next line, using namespace standard, simply tells the compiler that we're using a namespace with this code, and that's important because we're using a standard library file, and it simply means that we don't have to, whenever we call a standard library function, put std like this in front of it. It tells the compiler to look in that namespace for functions if it doesn't find them in the current translation unit. So again, that's a shortcut, and we'll cover that in a lot more detail later on when we talk about namespaces. But this is all part of a normal, standard, minimal C++ program, and so you'll see this a lot, and now you have a general idea of what it does. The next thing we see here is the main function. This is the main entry point for any C++ program. There always must be a main function, and there must be one and no more than one. The main function is declared like this, with these 2 arguments. Sometimes you'll see 3 arguments, sometimes you'll see no arguments. In fact, this is perfectly legal like that. I tend to include these standard arguments just because that's the standard way of doing it. And it's very common, and we won't actually even be using them, but they're very commonly there, and you need to know what they look like. Sometimes you'll see it done like this instead, with only one of these and a couple of square brackets, and that is also common, and you'll see it that way sometimes. Again, these arguments are just normally there. We're not actually going to use them. I put them there for completeness. What they're for is to get arguments from the command line when you're running this as an actual command line file, and we're going to be running it inside the IDE here. Or if you're on a PC, you'll be running at the command line, but you won't be putting arguments on the command line. Again, we'll talk about all this in more detail later on in the course. This is just an overview. So then we have a line of code, and this line of code here on line 7, that tells us to print this string down here in our console. And then you see return 0. Again, this is required. A main function must return a value, and it must return an integer value because you see it's declared as an integer function. And 0 in this case means success. So the standard thing for a main program to return is 0. Sometimes you'll see them return something else to indicate an error, but all of our main functions are going to return 0. So just another note, you'll see this done a couple of different ways, and I'll talk about this in more detail later on in this chapter. This puts function is a standard library function that puts a string in the console and a new line at the end of it. So that where you see this program ended with exit code 0, that happens on the line after it, so you can see your output without something else jammed up against the end of it. Sometimes you'll see this done with printf, which looks like this, and it does exactly the same thing. I'll go ahead and run this. And you see now we have program ended on the same line as the hello world because printf doesn't put in a new line. So if I want the new line, I have to do that, save and run. And there we have that result. Another way you'll often see this is with cout. I'm going to talk about this in a lot more detail later on in this chapter. You notice first I need to change C standard IO to IO stream, and then I can take out the printf function altogether and I can say cout and with 2 left angle brackets like that. And again, I need to include this new line. If I don't, it won't do it for me. And I'll save and run, and you see we get exactly the same result. Cout is a C++ class that operates in a very complex way to send stuff to the output stream, which is what we're seeing here on our console. I tend to prefer to use these standard functions like puts and printf. They're smaller, lighter weight, and faster, and work just as well for our purposes. And I'll talk about the difference and the distinction and why I make that choice later on in this chapter. So this is the basic form of a C++ program. As I said, we'll go into much more detail about all of these topics as we continue this course. But for now, it's just good to know how this is all structured and what these minimal required elements are. So let's delete our working copy, and I'm going to run clean, and I'll clear the console as well to prepare us for the next lesson.